Have you ever wondered about the astonishing secrets the universe holds? Are you curious about the incredible discoveries that have changed our understanding of space? From black holes to distant exoplanets, the cosmos is full of awe-inspiring phenomena waiting to be explored. Join us as we uncover 15 mind-blowing space discoveries you need to know. Join us as we delve into these amazing findings and see how they expand our knowledge of the universe. The first image of a black hole. In April 2019, the Event Horizon Telescope collaboration achieved a monumental milestone by capturing the first ever image of a black hole. This groundbreaking image revealed the supermassive black hole at the center of the galaxy M87, located about 55 million light-years from Earth. The image showcased a bright ring of light encircling a dark shadow, the event horizon, beyond which no light or matter can escape. This achievement was made possible by synchronizing 8 radio telescopes worldwide, creating an Earth-sized virtual telescope. This observation not only confirmed the existence of black holes, but also provided critical support for Einstein's theory of general relativity. The EHT's success marks the beginning of a new era in studying black holes, promising to reveal more about these mysterious cosmic giants. The discovery of gravitational waves. In 2015, the Laser Interferometer Gravitational Wave Observatory, or LIGO, made history by detecting gravitational waves for the first time. These ripples in space-time, predicted by Einstein's general theory of relativity, were caused by the collision of 2 black holes over 1 billion light-years away. This discovery opened a new window for observing the universe, allowing scientists to study cosmic events that were previously invisible. Gravitational waves have since been detected from multiple sources, including merging neutron stars. These observations have provided invaluable insights into the behavior of matter under extreme conditions and have confirmed the existence of binary black hole systems. The study of gravitational waves continues to revolutionize our understanding of the universe and its most violent events. The discovery of thousands of exoplanets. The search for exoplanets, planets outside our solar system, has been one of the most exciting areas of astronomy. The Kepler Space Telescope, launched in 2009, revolutionized this field by discovering thousands of exoplanet candidates. Among these, many are Earth-sized and reside in their star's habitable zone, where conditions might be right for liquid water to exist. Notable discoveries include Kepler 186f, an Earth-sized planet in the habitable zone of its star, and the TRAPPIST-1 system, which has 7 Earth-sized planets, 3 of which are in the habitable zone. These discoveries have profound implications for the search for extraterrestrial life and have expanded our understanding of the diversity of planetary systems in the galaxy. Hubble's Deep Field Images. The Hubble Space Telescope has captured some of the most iconic images of the universe, including the Hubble Deep Field and Hubble Ultra Deep Field. By focusing on a tiny, seemingly empty patch of sky for extended periods, Hubble revealed thousands of distant galaxies, some of which are among the oldest and most distant objects ever observed. These deep field images provide a glimpse into the universe's past, showing galaxies as they were billions of years ago. They have significantly advanced our understanding of galaxy formation and evolution, and have demonstrated the vastness and richness of the cosmos. The Hubble Deep Field images remain a testament to the power of space telescopes to explore the farthest reaches of the universe.
The Cassini-Huygens mission to Saturn.
The Cassini-Huygens mission, a collaboration between NASA, ESA, and ASI, provided an unprecedented view of Saturn and its moons. Launched in 1997, the Cassini spacecraft spent 13 years orbiting Saturn, sending back stunning images and valuable data. Among its most significant discoveries was the detection of active geysers on Enceladus, indicating a subsurface ocean that could potentially harbor life. The mission also revealed the complexity of Titan, Saturn's largest moon, with its lakes and rivers of liquid methane. Cassini's observations have transformed our understanding of the Saturnian system and highlighted the potential for life on its moons. The mission's legacy continues to influence planetary science and exploration.
Mars rover's discoveries.
Mars exploration has been significantly advanced by rovers such as Spirit, Opportunity, Curiosity, and Perseverance. These rovers have provided detailed analyses of Martian geology and climate, revealing evidence of ancient water activity and the potential for past life on Mars. Spirit and Opportunity, which landed in 2004, discovered signs of ancient riverbeds and minerals that form in the presence of water. Curiosity, which landed in 2012, found evidence of ancient lakes and organic molecules, suggesting that Mars could have supported microbial life in the past. Perseverance, which landed in 2021, is searching for signs of ancient life and collecting samples for future return to Earth. These rovers have revolutionized our understanding of Mars and paved the way for future human exploration. The discovery of dark energy. In 1998, astronomers made a groundbreaking discovery that the universe's expansion is accelerating, driven by a mysterious force known as dark energy. This discovery was based on observations of distant supernovae, which appeared dimmer than expected, indicating an increasing expansion rate. Dark energy is thought to make up about 68% of the universe's total energy content, yet its nature remains one of the biggest mysteries in cosmology. Understanding dark energy is crucial for determining the universe's fate. If the expansion continues to accelerate, it could lead to scenarios such as the Big Freeze, where galaxies drift apart and stars eventually burn out. The discovery of dark energy has profound implications for our understanding of the cosmos and the fundamental forces that govern its evolution.
The Kepler Space Telescope's exoplanet discoveries.
The Kepler Space Telescope has been instrumental in discovering thousands of exoplanets, greatly expanding our knowledge of planetary systems. By monitoring the brightness of over 150,000 stars, Kepler identified exoplanets through the transit method, detecting the slight dimming of a star as a planet passes in front of it. Among Kepler's most significant discoveries are Earth-sized and potentially habitable exoplanets. Kepler 186f, an Earth-sized planet in the habitable zone of its star, was a milestone in the search for Earth-like planets. Kepler's findings have shown that planets are common in the galaxy, and that many stars host multiple planets, suggesting that the conditions for life might be widespread.
The discovery of water on Mars.
The discovery of water on Mars has been a significant milestone in the exploration of the red planet. Evidence of water in various forms, including ice, vapor, and briny liquid, has been found, suggesting that Mars once had a more hospitable environment. The Mars Reconnaissance Orbiter detected hydrated salts in recurring slope lineae, indicating seasonal flows of briny water. Radar data from the Mars Express spacecraft revealed a subsurface lake beneath the southern polar ice cap. These discoveries have significant implications for the planet's potential to harbor life and for future human exploration. Water is a crucial resource for sustaining life and could be used for drinking, growing food, and producing fuel. Neutron star mergers. The observation of neutron star mergers has provided new insights into some of the most extreme events in astrophysics. In 2017, LIGO and Virgo detected gravitational waves from the merger of two neutron stars, followed by a gamma-ray burst and observations across the electromagnetic spectrum. This event, known as GW170817, marked the first multi-messenger observation, combining gravitational waves and light. The collision of neutron stars produces heavy elements like gold and platinum, helping scientists understand their origins. Observing these mergers has provided valuable information about the speed of gravitational waves, the properties of neutron stars, and the rate of neutron star mergers in the universe. Multi-messenger astronomy has become a powerful tool for studying the cosmos.
Fast radio bursts.
Fast radio bursts, or FRBs, are intense bursts of radio waves lasting only milliseconds but releasing enormous amounts of energy. Discovered in 2007, dozens of FRBs have since been detected, with some traced back to distant galaxies. The origins of FRBs remain largely unknown, but they are thought to originate from powerful astrophysical events. Repeating FRBs, such as FRB 121102, have provided additional clues, allowing astronomers to study these bursts in more detail. FRBs offer a unique opportunity to study the intergalactic medium and the large-scale structure of the universe. As radio waves travel through space, they interact with matter, providing information about the density and composition of the intergalactic medium.
New Horizons exploration of Pluto.
The New Horizons mission, launched by NASA in 2006, provided the first close-up images of Pluto and its moons. In 2015, New Horizons flew by Pluto, capturing detailed images and data that revealed a complex and diverse world. Among the most striking discoveries was the heart-shaped region called Tombao Regio, consisting of a vast, icy plain known as Sputnik Planitia. New Horizons also discovered active geology on Pluto, including nitrogen ice glaciers and towering ice mountains. The mission's findings extended beyond Pluto to its largest moon, Charon, which exhibited a varied landscape with deep canyons and a large equatorial ridge. The data from New Horizons has transformed our understanding of Pluto and the outer solar system. Oumuamua, the first interstellar visitor. In 2017, astronomers detected an unusual object passing through the solar system, later named Oumuamua. This was the first known interstellar object to enter our solar system, traveling on a trajectory that indicated it originated from outside our solar neighborhood. Oumuamua's characteristics were puzzling, including its elongated shape and non-gravitational acceleration. The discovery of Oumuamua provided a rare opportunity to study an object from another star system. Its origins and nature remain subjects of intense debate, with hypotheses ranging from a fragment of a larger body to an interstellar comet. Oumuamua confirmed that objects from other star systems can pass through our solar system, offering potential clues about the formation and evolution of planetary systems. The Cosmic Microwave Background, CMB. The Cosmic Microwave Background, CMB, is the afterglow of the Big Bang, providing a snapshot of the universe when it was just 380,000 years old. Observations of the CMB have been crucial for understanding the early universe, its composition, and its evolution. Missions like COBE, WMAP, and Planck have provided detailed measurements of the CMB, revealing its temperature fluctuations and polarization. These observations have confirmed key aspects of the Big Bang theory and provided precise measurements of the universe's age, composition, and geometry. The study of the CMB continues to be a vital tool for cosmology, helping scientists test theories of the universe's origin, evolution, and fundamental physics. Star formation insights from ALMA. The Atacama Large Millimeter Submillimeter Array, ALMA, in Chile has revolutionized our understanding of star formation and the early stages of planetary systems. By observing the universe in millimeter and submillimeter wavelengths, ALMA can peer through dust clouds that obscure visible light, providing detailed images of star-forming regions and protoplanetary disks. ALMA's observations have revealed intricate structures in protoplanetary disks, such as gaps and rings, indicating the presence of forming planets. It has also detected complex organic molecules in these disks, providing clues about the chemical processes that lead to the formation of life-bearing planets. ALMA's findings are helping to answer fundamental questions about the formation and evolution of planetary systems. These 15 mind-blowing space discoveries have expanded our understanding of the universe and opened up new frontiers in astronomy and astrophysics. From black holes to exoplanets and interstellar visitors, each discovery brings us closer to unraveling the mysteries of the cosmos. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep discovering the world's wonders. Have you ever gazed up at the night sky and wondered what bizarre, otherworldly places might be out there? The universe is filled with exoplanets so strange and extreme that they defy imagination. From planets hotter than stars to worlds made entirely of ice, these discoveries redefine what we thought was possible. Join us as we take a journey to explore the 10 strangest exoplanets discovered so far. Each one will blow your mind, so stick around and let's dive into the cosmos together. Kelt 9 billion, a scorching inferno. Meet Kelt 9b, a planet so blisteringly hot it challenges the boundaries of planetary science. Orbiting a star twice as hot as our Sun, this gas giant experiences daytime temperatures exceeding 7,800 degrees Fahrenheit. That's hotter than some stars. The extreme heat has stripped the planet of its atmosphere's molecules, breaking them down into their basic atomic components. This planet orbits so close to its host star that a year lasts only about 1.5 days. Its proximity causes it to be tidally locked, meaning one side is perpetually facing the scorching star while the other remains in darkness. Scientists speculate that the night side might be slightly cooler, but cooler is relative when the entire planet is engulfed in unrelenting heat. What makes Kelt 9b even more extraordinary is that it's gradually evaporating. The intense radiation from its star is blowing its atmosphere away into space, creating a glowing tail, much like a comet. This phenomenon provides astronomers a rare glimpse into atmospheric escape, a process that's reshaping our understanding of planetary evolution. Traveling to Kelt 9b isn't an option, it's inhospitable beyond imagination, but studying it reveals how diverse and extreme planets in our universe can be. It's a fiery example of how exoplanets push the limits of what we consider possible in the cosmos. Gliese 436 billion, the ice on fire world. Gliese 436b seems like a contradiction of nature. Imagine a planet covered in burning ice. Located about 30 light-years away, this Neptune-sized world defies expectations with its bizarre mix of heat and ice. Its surface temperature is a scorching 800 degrees Fahrenheit, yet water exists as a solid ice mantle, compressed by the planet's immense gravity. This scorching world has a thin atmosphere, primarily composed of hydrogen, helium, and methane, which traps heat. Despite the intense temperatures, the high pressure on the planet keeps water locked in a strange, solid state called hot ice. This exotic form of water remains stable even under extreme heat, an incredible reminder of how physics behaves differently in alien worlds. Adding to the intrigue, Gliese 436b completes an orbit around its host star in just 2.6 Earth days. This tight orbit means the planet is exposed to constant stellar radiation, which further accentuates the paradox of its fiery, ice-covered surface. This otherworldly discovery shows how diverse exoplanets can be, challenging our understanding of what's scientifically possible. Gliese 436b is a testament to the universe's endless creativity, blending fire and ice in a way that can only exist far beyond our solar system. HD 189733b, the glass rain planet. Known as Osiris, HD 209458b is a gas giant slowly being ripped apart by its parent star. Located 150 light-years away, this exoplanet is losing its atmosphere to space at an astonishing rate due to its proximity to its host star. It's a perfect example of a hot Jupiter, a gas giant orbiting extremely close to its star. Osiris experiences extreme ultraviolet radiation that heats its atmosphere, causing hydrogen and helium to escape into space. This process forms a massive tail of gas trailing behind the planet, making it resemble a comet more than a traditional planet. This tail stretches thousands of miles and offers a fascinating glimpse into planetary disintegration. Astronomers have even detected heavier elements like oxygen and carbon in the escaping atmosphere. This discovery is groundbreaking, as it allows scientists to analyze the chemical composition of an exoplanet's atmosphere in detail. The fate of Osiris provides an eerie glimpse into the potential endgame for other exoplanets orbiting too close to their stars. It's a powerful reminder of the delicate balance planets must maintain to survive the harsh realities of space. Kepler 16b, the Tatooine planet. Kepler 16b is a real-life version of Tatooine from Star Wars, a planet that orbits not one but two stars. This celestial oddity is located about 200 light-years away and is a gas giant roughly the size of Saturn. Its dual suns create a surreal, ever-changing skyline that alternates between single and double sunsets. The planet lies in a circumbinary orbit, meaning it revolves around both stars as they dance together in a cosmic waltz. Despite its dramatic skies, Kepler 16b is surprisingly cold, with temperatures averaging around -100 degrees Fahrenheit. This chill is due to the distance from its host stars, which provide just enough light to illuminate its surface without warming it significantly. Kepler-16b's discovery confirmed that planets can form and survive in binary star systems, a finding that expands the possibilities for where planets might exist in the universe. This revelation has inspired scientists to explore the dynamics of binary systems further, opening the door to more discoveries in the future. Though uninhabitable, Kepler-16b sparks the imagination with its resemblance to science fiction worlds. Its existence proves that the universe holds surprises beyond anything we could dream up in fiction. 55 Cancri E, the lava world. 55 Cancri E is a planet of extremes. Found 41 light-years away in the Cancer constellation, this rocky super-Earth is locked in a perpetual furnace. With one side permanently facing its star, the planet experiences temperatures soaring over 4,400 degrees Fahrenheit. On the other side, where starlight never reaches, temperatures plummet drastically, creating a world of stark contrasts. This hellish planet is theorized to have rivers of lava flowing on its day side. Its surface glows with molten rock, illuminated by its blistering star. Scientists also suspect that the planet's atmosphere is dense with vaporized minerals, adding to its fiery ambience. The interaction between the extreme heat and the planet's unique geology creates an environment where lava oceans could exist, constantly churning and reshaping the surface. What makes 55 Cancri E even more captivating is its unusual orbit. A year on this planet lasts only 18 Earth hours, meaning it hurtles around its star at breakneck speeds. The extreme proximity to its host star also causes significant tidal heating, contributing to its molten state and making it an active and volatile world. As bizarre as 55 Cancri E sounds, its study offers scientists valuable insights into planetary formation under extreme conditions. This lava world is a testament to how planets can evolve into scorching wastelands that challenge our perceptions of habitability. WASP-12 billion, the planet being consumed. WASP-12b is a doomed world, slowly being devoured by its host star. Located about 1,400 light-years away, this gas giant orbits perilously close to its star, completing an orbit in just over 1 Earth day. Its proximity subjects the planet to immense gravitational and radiation forces, causing its atmosphere to stretch and form an elongated shape rather than the typical spherical form of planets. The intense radiation from the star heats WASP-12b to temperatures around 4,000 degrees Fahrenheit, making it one of the hottest known exoplanets. This heat has caused the planet's outer layers to expand and leak into space, forming a trail of escaping gases. Essentially, WASP-12b is being consumed alive, losing about 189 quadrillion tons of material every year. Astronomers studying this phenomenon have likened it to a celestial version of vampirism, where the host star is draining the planet of its lifeblood. Over time, this will result in WASP-12b being entirely obliterated, leaving nothing but a ghostly ring of debris around the star. This dramatic process offers a rare glimpse into planetary destruction, a stage in the life cycle of planets that's difficult to observe directly. WASP-12b's tragic fate reminds us of the fragile balance planets must maintain to survive the harsh realities of space. TRES-2 billion, the darkest planet. TRES-2b, located about 750 light-years from Earth, is often called the Black Planet due to its astonishing ability to absorb light. This gas giant reflects less than 1% of the starlight that hits it, making it darker than coal. Despite being bathed in the light of its host star, the planet remains eerily dark, with only a faint red glow caused by its internal heat. The reason for TRES-2b's darkness lies in its unusual atmosphere, which lacks reflective clouds and is rich in light-absorbing chemicals like titanium oxide. These compounds trap heat and light, giving the planet its pitch-black appearance. The lack of an atmosphere capable of scattering light further enhances its shadowy nature. Although it's cloaked in darkness, TRES-2b is incredibly hot, with temperatures soaring to over 1,800 degrees Fahrenheit. The stark contrast between its searing heat and its inky blackness makes it one of the most intriguing exoplanets ever discovered. Scientists are still unraveling the mystery of why TRES-2b is so exceptionally dark. Studying it could provide insights into atmospheric compositions and help identify similar worlds in the future. TRES-2b is a haunting reminder of how alien and diverse planets beyond our solar system can be. PSRB 16 2026 b Methuselah, the ancient planet. Nicknamed Methuselah for its incredible age, PSRB 162026b is the oldest known planet in the universe, with an estimated age of 12.7 billion years. That's nearly 3 times the age of Earth. Orbiting a binary system composed of a pulsar and a white dwarf, Methuselah is located in the globular cluster M4, about 12,400 light-years away. This gas giant challenges everything we know about planetary formation, as it emerged when the universe was less than 1 billion years old and lacked many of the heavier elements needed to form planets. Its existence suggests that planets can form under a broader range of conditions than previously thought. Methuselah's orbit around its host stars is both stable and extraordinary, taking about 100 Earth years to complete. This leisurely pace offers scientists a fascinating opportunity to study the gravitational interactions within its unique binary system. Despite its ancient origins, Methuselah is a robust planet that has endured countless cosmic events, including nearby supernovae and the gradual aging of its host stars. It's a true survivor, offering a window into the universe's earliest days. HD 189733b, the Glass Rain Planet. HD 189733b, a stunningly violent world, is located 64 light-years away in the constellation Vulpecula. This gas giant has an atmosphere dominated by silicate particles, which condense to form clouds of molten glass. The result is a planet where it literally rains glass, blown sideways by winds exceeding 5,400 miles per hour. The planet's deep blue hue, similar to Earth's oceans, is caused by the scattering light of these silicate particles. However, the similarities to Earth end there. With surface temperatures reaching a scorching 1,700 degrees Fahrenheit, HD 189733b is a hostile and volatile world. The extreme winds and glass rain are driven by the planet's tight orbit around its host star, which is completed in just over 2 Earth days. This proximity subjects it to intense radiation and tidal forces, fueling its chaotic weather patterns. HD 189733b is a prime example of how alien and extreme weather can get on exoplanets. Studying this world offers scientists clues about atmospheric dynamics and helps refine techniques for detecting similar phenomena on distant planets. Ogle 2005 BLG 390lb, the coldest planet. Ogle 2005 BLG 390lb, located a staggering 21,500 light-years away, is one of the coldest exoplanets ever discovered. Dubbed the Hoth planet after the icy world in Star Wars, this frozen super-Earth exists in the far reaches of its host star's habitable zone. With surface temperatures plummeting to -370 degrees Fahrenheit, it's a desolate, icy wasteland. This frigid planet orbits a faint red dwarf star, which provides little heat and light. The planet's vast distance from its star results in an extremely long orbital period, taking about 10 Earth years to complete one revolution. Despite its cold environment, Ogle 2005 BLG 390lb's discovery was groundbreaking, as it was one of the first planets detected using gravitational microlensing. Its icy surface suggests that it could potentially harbor frozen water, sparking curiosity about its composition and the possibility of life beneath its frozen crust. While unlikely to be habitable, studying Ogle 2005 BLG 390lb has expanded our understanding of where planets can exist and thrive. This frozen world highlights the incredible range of environments exoplanets can offer, proving that even the most inhospitable conditions can yield fascinating discoveries. And there you have it, the 10 strangest exoplanets discovered so far. Each of these alien worlds challenges our understanding of the universe and expands our imagination. If you enjoyed this cosmic journey, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep exploring the extraordinary wonders of space.
Think about it. What if something exists, simply because it always has? No creator, no origin, just an infinite loop of existence. In Dark, we see this play out with the Stranger giving Jonas a time machine that he later builds himself. But here's the problem. Who actually invented it first? That's the Bootstrap Paradox, a time loop with no beginning, no end, and no logical explanation. And trust me, once you start thinking about it, you'll never see time the same way again. What is the Bootstrap Paradox? Imagine you find an old book filled with groundbreaking scientific discoveries. You study it, memorize every formula, and years later, you publish the same book. But here's the twist. Where did the original knowledge come from? Who actually wrote it first? This mind-bending scenario is the essence of the Bootstrap Paradox, a time loop where information or objects seem to exist without ever having been created. The Bootstrap Paradox is one of the strangest puzzles in time travel theories. Unlike the grandfather paradox, which questions whether you could erase your own existence by changing the past, this paradox doesn't break time. It bends it in a way that challenges our entire understanding of cause and effect. It's a loop with no clear beginning, no point of origin, and no logical creator. Everything exists simply because it always has. But does that mean it ever truly existed at all? Think about it. What if a scientist from the future goes back in time and teaches Einstein about relativity? Einstein then grows up, develops the theory, and the future scientist learns it from Einstein's published work before traveling back again. Who originally came up with the idea? If the information has no starting point, does that mean it's been borrowed from nowhere? This paradox is not just a thought experiment, it has been a major inspiration in science fiction, philosophy, and theoretical physics. The concept forces us to question everything we know about time, existence, and reality itself. If something can exist without being created, does that mean the past, present, and future are already written? Or is time more flexible than we ever imagined? The Bootstrap Paradox isn't just about time travel, it's a riddle that teases the very limits of human comprehension. And if we ever unlock the secrets of time manipulation, we might find that reality is much stranger than fiction. Bootstrap in fictions. Science fiction has been playing with the Bootstrap Paradox for decades, crafting mind-bending stories that leave us questioning everything. Let's start with a simple yet mind-twisting example: a musician who learns to play a song from an old recording. Years later, he records the same song, and that recording becomes the very one he learned from. So, who originally composed it? If you can't answer that, congratulations, you've just encountered a Bootstrap Paradox. One of the most famous examples comes from Doctor Who. The Doctor explains the paradox using Beethoven. Imagine you go back in time to meet Beethoven but find out he never existed. Shocked, you publish all of his compositions from memory, becoming Beethoven yourself. But if you only knew his music because of the future, and the future only knew it because of you, where did the music actually come from? Then there's the Terminator, where Skynet sends a killer robot back in time to eliminate John Connor before he can lead the human resistance. But here's the twist. The remnants of the destroyed Terminator become the foundation for Skynet's creation. That means Skynet was never invented. It just always existed because of a time loop. Christopher Nolan's Tenet plays with this paradox on a deeper level. Characters manipulate time by passing information and objects back and forth, making it impossible to determine an original source. A character gives instructions for a mission that will save the world, but those instructions only exist because they were received from the future. No origin, no beginning, just an infinite loop of cause and effect. And let's not forget the Harry Potter series, where Harry receives the invisibility cloak from Dumbledore, which was passed down through generations. But what if someone had traveled through time and placed the cloak in the past for Harry to receive? That would create an object with no true origin, forever cycling through time. These stories don't just entertain us, they make us question how time really works. If something exists only because it always has, does it truly exist? Or are we all just characters trapped in a story that has already been written? Theoretical implications. Time travel isn't just a wild fantasy, it's something physicists seriously consider. And the Bootstrap Paradox is one of its strangest implications. If an object, an idea, or even a person loops through time without an origin, does that mean it was never truly created? Can information exist without a source? This paradox breaks the very thing we rely on, cause and effect. In our everyday world, everything follows a logical sequence. You wake up, you get dressed, you go about your day, one event causes the next. But the Bootstrap Paradox throws all of that out the window. Imagine a scientist who builds a time machine after reading blueprints found in a mysterious box. Years later, he travels back in time and leaves the same blueprints in that very box for his younger self to find. Who originally designed the machine? The answer? No one. The information just exists, trapped in a self-sustaining time loop. This idea isn't just a sci-fi gimmick. Quantum physics suggests that time might not be as linear as we think. Some theories propose that the past, present, and future all exist simultaneously, and what we perceive as time moving forward is just our limited way of experiencing reality. If that's true, then the Bootstrap Paradox isn't just possible. It might be how reality actually works. The paradox also raises an unsettling question. Can we ever truly create something original? If ideas, inventions, or knowledge can theoretically be passed through time without a real origin, does that mean the future has already happened? If so, is free will just an illusion, and are we simply following a script that has already been written? Some scientists believe that the paradox suggests a predetermined universe, where everything, including every thought, every action, and every discovery, was always meant to happen. Others argue that reality would prevent these loops, maybe through quantum randomness or some undiscovered principle of time. But until we truly understand time, the Bootstrap Paradox remains one of the greatest mysteries of the universe. Related paradoxes. The Bootstrap Paradox isn't the only mind-melting mystery in time travel. It's just one piece of a much larger puzzle that challenges everything we know about cause and effect. If you think an object existing without an origin is weird, wait until you hear about these other paradoxes that make time itself seem like a cosmic prank. First up, the grandfather paradox, a classic dilemma in time travel. Imagine you go back in time and accidentally prevent your grandfather from meeting your grandmother. That means one thing: you were never born. But if you were never born, then who went back in time to stop them from meeting? Just like that, you've erased your own existence, creating a contradiction that time seemingly can't resolve. Some scientists suggest that time might self-correct to prevent such paradoxes, but if it doesn't, reality itself could break. Then there's the predestination paradox, which is like the Bootstrap Paradox but applies to events instead of objects. Picture this: you have a vision of a tragic accident, so you rush to stop it. In doing so, your actions accidentally cause the very accident you were trying to prevent. The event was always going to happen. Your attempt to change it only ensured it did. This paradox suggests that some things are just inevitable, no matter what we do. The Fermi paradox isn't a time paradox, but it's worth mentioning because it deals with another big mystery. If the universe is so vast, where is everyone? Could time loops or paradoxes be preventing civilizations from developing? Could an advanced species have discovered time travel and accidentally wiped itself from existence? It's a terrifying thought, but one that scientists seriously consider. Lastly, let's talk about the twin paradox. Not quite a contradiction, but a bizarre outcome of Einstein's theory of relativity. If one twin travels near the speed of light and returns to Earth, they'll have aged much less than the twin who stayed behind. This means time isn't fixed, it's flexible, changing depending on speed and gravity. If time itself is this strange, maybe paradoxes aren't impossible at all. Maybe they're just how time really works. Reflection. The Bootstrap Paradox is more than just a weird thought experiment. It's a challenge to everything we believe about time, reality, and even existence itself. If something can exist without ever being created, what does that say about the universe? Are we living in a reality where time isn't a straight line but an infinite loop, constantly feeding itself with knowledge, objects, and events that never had an origin? This paradox forces us to ask a deeper question. Is time truly linear? Or are we just perceiving it that way? Imagine if past, present, and future all exist at once, and we're simply moving through them like a needle on a record. What if history isn't written before or after? What if it just is? Some physicists argue that time might be a block, where everything has already happened, and we're just experiencing it in sequence. If that's true, then maybe Bootstrap paradoxes aren't violations of time. Maybe they're just proof that time works differently than we think. But here's the real kicker. If a time loop can create something from nothing, does that mean free will is just an illusion? If knowledge, objects, or even events exist because they always have, does that mean our choices are already predetermined, or do we have the power to break the cycle? The Bootstrap Paradox doesn't just raise questions about time, it makes us rethink the very nature of choice, destiny, and existence. And what if this paradox isn't just fiction? Imagine a future where time travel is possible, and people start sending knowledge back through time. Would we ever be able to tell what ideas were truly original and which ones were borrowed from a future that hasn't even happened yet? If history can be rewritten, would we ever know what the real timeline was? The mystery of time travel remains unsolved, but one thing is certain: the Bootstrap Paradox is a puzzle that refuses to be neatly explained. Maybe the answers are hidden in the future. Maybe they've already been discovered, just waiting for someone to bring them back in time. Or maybe, just maybe, they were never created in the first place. Time travel, paradoxes, and infinite loops. The universe is stranger than we can imagine. The Bootstrap Paradox is just one of many mysteries that challenge everything we know about time. But what if time isn't broken? Just misunderstood? If you love exploring mind-bending concepts like this, subscribe to InnoVision Tech for more deep dives into futuristic science, technology, and the unknown. Hit the like button, drop a comment, and let's keep pushing the boundaries of imagination. Imagine waking up one day, only to realize the universe itself has turned against us. No warnings, no second chances, just pure, unstoppable destruction. From fiery solar explosions to invisible death rays from space, the cosmos is filled with forces powerful enough to wipe out humanity in an instant. Scary? Absolutely. But what's even scarier? Some of these threats are completely unpredictable. Today, we're diving into the 7 most terrifying cosmic events that could end life as we know it. So buckle up, because once you hear these, you might never look at the night sky the same way again. Asteroid impacts. Imagine this. You're enjoying your morning coffee, scrolling through your phone, when suddenly, news headlines scream, "Massive asteroid detected on a collision course with Earth." Panic sets in, scientists scramble, governments go silent, and all you can do is watch as a giant space rock, possibly the size of a city, barrels toward our planet at tens of thousands of miles per hour. Sounds like a sci-fi movie, right? But here's the terrifying truth. This has happened before, and it could happen again. 65 million years ago, an asteroid roughly 6 miles wide slammed into what is now the Yucatan Peninsula, triggering a firestorm that wiped out the dinosaurs. If something similar happened today, the results would be even more catastrophic. The impact would unleash energy equivalent to billions of nuclear bombs. First, there'd be an explosion so powerful that anything within hundreds of miles of ground zero would be instantly vaporized. Shockwaves would rip through the planet, causing massive earthquakes and tsunamis that could swallow entire coastlines. But the worst part? The aftermath. Dust and debris would fill the atmosphere, blocking out the sun for months, maybe even years. Temperatures would plummet, crops would fail, a global winter could starve millions, and the scary part? We've had close calls. Asteroids like Apophis and 2012 DA-14 have brushed past Earth in recent years. NASA and other space agencies monitor these threats, but not all of them are detected in time. So, what if the one that ends us is already on its way? Gamma-ray bursts. Imagine waking up one morning, stepping outside, and feeling an eerie silence. No birds chirping, no wind, just an unsettling stillness. Then, in an instant, a blinding flash erupts in the sky. You don't hear a sound, but in that moment, the fate of Earth is sealed. You've just witnessed a gamma-ray burst, one of the most violent and deadly phenomena in the universe. Gamma-ray bursts are cosmic death rays, unleashed when massive stars collapse into black holes, or when neutron stars violently merge. These bursts can release more energy in a few seconds than the sun will in its entire lifetime. If a GRB were to occur in our galactic neighborhood, and was aimed directly at Earth, it would be like setting off a billion nuclear bombs. But instead of an explosion, the danger comes from invisible radiation. The first thing it would do is strip away our ozone layer, the only thing protecting us from deadly space radiation. Without it, ultraviolet rays from the sun would scorch the planet, leading to mass extinctions. Plants would wither, animals would die, and humans, well, let's just say sunscreen won't save you. Scientists believe that a past gamma-ray burst may have caused a mass extinction event on Earth hundreds of millions of years ago. The scariest part? We wouldn't even see it coming. It would travel at the speed of light, and by the time we noticed it, it'd already be over. Supernova explosions. We think of stars as distant, twinkling lights in the sky, but don't be fooled. Some of them are ticking time bombs. And when one of these colossal stars reaches the end of its life, it goes out with a bang. Literally. A supernova explosion is one of the most powerful forces in the universe, capable of outshining entire galaxies. But if a nearby star were to go supernova, it wouldn't just be a spectacle, it would be our doom. The first thing that would happen? A deadly burst of radiation. X-rays and gamma rays would flood our planet, damaging DNA, causing mutations, and wiping out entire species. But the real horror starts in the atmosphere. The blast would shred our ozone layer, leaving us vulnerable to the sun's lethal radiation. In a matter of months, crops would fail, food chains would collapse, and survival would become a desperate fight against a planet turning hostile. So, how close would a star need to be to threaten us? Scientists say about 50 light-years away. Thankfully, no known stars that close are expected to explode anytime soon. But space is unpredictable. Betelgeuse, one of the largest stars visible in our night sky, is a prime supernova candidate. And while it's far enough away to not directly harm us, it serves as a chilling reminder. Somewhere, sometime, a supernova will happen close enough to spell our end. The only question is, when? Rogue black holes. We've all heard of black holes, massive invisible monsters lurking in space, devouring everything that comes too close. But what if I told you there are rogue black holes, wandering the galaxy like cosmic predators, unseen and unstoppable? One could be heading our way right now and we'd have no idea. Unlike the supermassive black holes at the centers of galaxies, rogue black holes are smaller but no less terrifying. They drift through space after being ejected from their home systems, traveling at mind-blowing speeds. If one were to pass through our solar system, it wouldn't need to suck us in to destroy us. Its immense gravity could distort planetary orbits, sending Earth spiraling toward the sun or hurling us into the cold abyss of deep space. Either way, life as we know it would be over. And the scariest part? We can't easily detect them. Black holes don't emit light, making them nearly impossible to spot against the darkness of space. Scientists estimate that there could be millions of these nomadic nightmares roaming the Milky Way. So while we gaze at the stars, wondering what lies beyond, an unseen destroyer might already be approaching, and by the time we realize it, escape will be impossible. Solar superflares. The sun, our life-giving star, the reason we exist. But what if the very thing keeping us alive suddenly turned against us? Imagine waking up to a world without electricity, no internet, no phones, no running water, no cars, a complete and total blackout. This isn't a dystopian fantasy, it's what could happen if the sun unleashed a solar superflare. Solar flares are bursts of energy from the sun, and while we experience small ones regularly, a superflare would be a completely different beast. If one were to hit Earth, the first thing we'd notice is an eerie, ghostly aurora lighting up the sky, even in places that never see the northern lights. Beautiful? Yes. Terrifying? Absolutely. Because within hours the radiation would fry satellites, knock out power grids, and disrupt everything from GPS to banking systems. But that's just the start. A powerful enough solar storm could heat up the atmosphere, expand it, and cause space debris and satellites to spiral downward, crashing back to Earth. The worst-case scenario? The Carrington event, a solar storm that hit Earth in 1859, was so powerful that telegraph wires caught fire. If something that's strong or worse happened today, it would send us back to the Dark Ages. Billions could struggle to survive without power, food supply chains would collapse, and modern civilization as we know it would be on the brink of total chaos. The sun gives life, but one bad flare and it could take it all away. Cosmic collisions. We tend to think of space as an endless void, but in reality, it's a cosmic battlefield. A place where galaxies, stars, and planets are constantly moving, sometimes colliding in spectacularly destructive ways. And Earth? We're just a tiny, fragile speck caught in the middle of it all. Now you might be thinking, how could we possibly collide with something out there? Space is massive. Well, tell that to the Andromeda Galaxy, which is currently on a direct collision course with the Milky Way. That's right, our entire galaxy is set to merge with Andromeda in about 4.5 billion years. When that happens, stars will be ripped apart, solar systems will be flung into the void, and Earth could be thrown out of orbit entirely. But we don't need to wait billions of years for destruction. There are rogue planets, massive, Jupiter-sized worlds that have been ejected from their home systems, wandering aimlessly through space. If one of these dark, frozen giants passed too close to our solar system, it could alter the orbits of planets, sending Earth tumbling toward the sun, or out into deep space where we'd freeze to death. Space isn't just vast, it's dangerous. And the worst part? These collisions don't announce themselves, they just happen. Vacuum decay. Alright, buckle up, because this one is the most mind-bending of them all. Forget asteroids, black holes, or gamma-ray bursts. This is the end of everything. The universe as we know it might not be stable. In fact, some physicists believe that we're living in what's called a false vacuum, a delicate, temporary state that could collapse at any moment. And when it does, game over. It's called vacuum decay, and it starts with a quantum event so random, so unpredictable, that it could have already happened somewhere in the universe. If it did, it would create a tiny bubble of true vacuum, expanding at the speed of light. The moment this bubble reaches us, reality as we know it ceases to exist. No warning, no escape, just instant annihilation. Imagine looking at the night sky and suddenly, nothing. The stars blink out, the planets vanish, and in less than a fraction of a second, the laws of physics rewrite themselves. The terrifying part, there's no way to predict it, there's no way to stop it. It could happen a billion years from now, or right now, and if it did, you wouldn't even have time to realize it. 1 second you're here, the next, you're erased from existence along with everything else. Sounds terrifying, right? But hey, at least with vacuum decay we'd never see it coming. So, sweet dreams if you can still sleep after this. Space is vast, beautiful, and absolutely terrifying. While these cosmic threats sound like something out of a sci-fi movie, they're very real possibilities, though thankfully most are unlikely to happen anytime soon. But the more we explore the universe, the better we can prepare for the unknown. If you enjoyed this deep dive into the mysteries of space, don't forget to like, subscribe, and hit the bell icon for more mind-blowing science and tech content. This is InnoVision Tech, and we'll see you in the next video, if the universe doesn't get us first.